What is 29th?
It's been four. Been 2 days.
So I don't think you should write this part down, but I just want to kind of again review something that you have learned before. Your current understanding of parabolas is that I would give you a quadratic like this, like y equals 2x squared minus 5x plus 3. And there was a point in our history together where we would have graphed that, and we would have done it by finding the vertex. Negative b over 2a probably doesn't ring any bells. Maybe it does. And then eventually you find the vertex, and then you go and you build a graph from the vertex. What I want to do today is just totally, like I said, is just shift your perspective on this completely. So what we're going to think of parabolas now as is this. You're going to want to sketch this. I won't use graph paper, kind of out of respect for what you're working with. I'll do the same until I get to the delta math, because then it does it for me. But for now, I just want you guys to draw an x-axis and a y-axis. I am going to cheat and use my straight line drawing tool.
Cheat. Wonders cheating.
That's okay.
Cheat.
So what I want you to understand going forward about a parabola is that it's not what maybe you've perceived it to be. So I want us all just to we're going to make a line, and it doesn't have to be perfect, but let's just say for the sake of argument that that is at 2 on the y-axis. I don't want this to be completely like ambiguous. I want there to be something to hold on to. Okay. And then we're going to put another point. Let's put it like up above it. And I'll put it right about here. And I don't think I like the scaling of where I put that. I think I want to move him up just a little bit like this. It doesn't have to be perfect. I guess I worry about stuff like this, but um, so there is a parabola that exists. This is really what you need to listen to, I think. You can get through this, by the way. You can robotically write equations of parabolas without really understanding what I'm about to say. But the way and the reason a parabola comes into existence is because somewhere between these two things, I'm not going to give you their names yet, but somewhere in between them, i.e., right smack in the middle, is a point that we call the vertex. Now, the thing about the vertex is that it's the same distance away from the yellow dot as it is from the red line. That's very important. And I want you to start thinking about like magnetic forces at play. So think of that point being suspended in between two magnets, and it's like it's just stuck literally floating in the middle, right? Well, as the point moves out to the side, something changes. And what happens is we have to keep the distance between the purple point and the yellow point and the purple point and the red line the same. So if I put another point, say right here, don't draw this point. That point would not be on this parabola, and I'll tell you why. It's because, let me zoom in a little bit so you can see this a little bit better. We would all agree that this distance from the yellow dot to the purple point is no longer equivalent to this distance from the purple point to the red line. Do you agree?
Mm-hmm.
So that point would not be on this particular parabola. So if I wanted to make a point that is on the parabola, I need to be cognizant of that. I want to say, like, I need to put you someplace where the distance between the yellow dot and the red line remains consistent. I might do something more like this. And that way there, I'm trying hard here to show you that I want this distance and this distance to remain the same. And I don't know if I accomplished it, but maybe you get the idea. As you do this over and over and over and over again, what happens is you eventually come up with an infinitely large set of points that looks like this. And this is the shape that you know as a parabola. And it works on both sides as well. So it can go this way, just as it can go the other way. So if I've done this even remotely artistically well, which honestly I'd be surprised if I did, but the implication here is that if I were just to pick some random point on that curve, I would be able to say that the forces match. This distance from here to here matches this distance from here to here. So provided that those distances remain equivalent, then you are a point on the parabola. It's a little bit more complex than this, but it's the same as when someone first taught you what's a circle. It's such a simple question, but what really is a circle? It's the set of all points that are the same distance from a fixed point, right? Think of like the example of like a dog on a leash. So like if you took your dog to the park and you put down one of those stakes that the leash goes into and you stake it down, and if you got a really hyper dog, feed it a bunch of chocolate or something like that, as it runs around and barks, what it's tracing is a circle. And the reason is because its distance from that center point remains fixed. That's kind of how this is working. It's just coming from multiple pulling directions, not just one. So that's behind the scenes what a parabola is and always has been. So what do you think happens to the shape of the parabola? Let me see if I can fit this on the same in the same workspace here. So if I do, I'm going to keep my red line in the same place, by the way. So I think that will help us to make sense of this. So if I keep my red line in the same place, which will remain at a height of 2. But if I take that yellow dot and I move it down, instead of it being, by the way, I meant for it to be up at 6. I don't think did I ever say that out loud? I
Yeah.
apologize for that. I meant for him to be up at a height of 6. So in my mind, I was trying to like triple. So I don't, yeah, I think I did okay. So let's take the yellow dot down to like 4. Got it? So what this means now is that the purple dot, the vertex, would have to be right smack in between the two, which is right about here. What do you theorize happens to the shape of the parabola as those two, which I haven't named the as yet unnamed red and yellow items, when I get them closer, what happens to the shape? You think it widens up? Let's take a look. So just by eyeballing this, if I put a point like right here, well, here, let me try to make it skinnier. Let me counter what Anderson said, and let me just go up like this. Is that going to work for us if I go up like that? It's not, is it?
Mhm.
So I think what you're saying is pretty dang cool, that as that distance decreases, then perhaps we can say that the opening width is going to increase. Because to make this work, I think I need to shoot out a little bit harder, like maybe come across more like this way so that these distances match, right? So that's how a parabola comes into existence. But I agree with you that as that distance shrinks, then our parabola is going to get fatter. And if we wanted that distance, if we wanted the parabola to get skinnier, like Slim Fast Diet, then we'd want to stretch the red and the yellow. So let's talk about what these things are. This part, you're going to need some vocab. So without this, you'd be pretty much cooked. This point is called the focus. This red line is called the directrix. And my goal for the day, I had a couple of goals. Goal one was just to get that picture in your head of how a parabola it exists because of the constant balance and tug between the focus and the directrix. I don't know if I've accomplished that goal, but I think you kind of get the idea. Goal number 2 today is, can I get these students to write the equation of a parabola if all I give them is the focus and the directrix? And the answer in about 12 minutes will be, yeah, I think we got this. So this is objective number 2 is, let's see if we can write equations of parabolas if all we know is the focus and the directrix. So the first thing I'm going to need you to do, I never like doing this to you when I feel like maybe we're not ready for it, but let's just get this out of the way. We're going to have two equations that we're going to use throughout this lesson.
Oh, Brady, who do you son?
You're gonna,
The Packers?
oh, good God.
Awesome.
Something I did realize I should have mentioned is that your focus and directrix do not have to be vertically aligned. We will now see parabolas that are oriented horizontally. So you can have a directrix that is a vertical line, and you can have a focus that is off to the side of it like this. Okay. So I just wanted to be clear about that, that we're going to see parabolas that open up, that open down, that open to the right, and that open to the left. What's one thing this far into the lesson that you could say about the vertex? If I were going to go up there right now and plot my purple vertex, where would you tell me to put it? You know this. Halfway between the yellow and the red, right? Good. So just so we're clear on this, because this distance is going to become really important. But regardless of the situation, if you know your focus and you know your directrix, you can rest assured that the vertex is going to be halfway between them. Right. And when I say half, like Mr. Manlove taught you in geometry, when we talk about the distance from a point to a line, we're very clearly talking about the straight perpendicular distance, right? Not a crooked distance. So anyhow, we're going to see parabolas that open to the right. So like you could infer that this parabola opens to the right because of the location of the focus and the directrix. If I placed the focus on the other side, like over here, then the vertex would sit here, and you would infer from that that the parabola opens to the left, right? So, I mean, the parabola is always going to be predictably based and sandwiched right between the focus and the directrix. So here are the two formulas I need you to know first of all. Write these down and write them down neatly because you're going to be using them a lot. So the first formula you're going to use is for a parabola that opens up or down. If you have, and you'll know, right? Based on the relative locations of the focus and the directrix. If a parabola opens up or it opens down, you're going to use this formula. And before I even talk to you about what all those letters mean, let's just do the other version of this. It would be a real stretch for me to ask this, but that's never stopped me before. Come on, you big brainiacs. Let's say we have a parabola that opens to the left or the right, regardless. Anyone want to take a stab at what we do to modify this formula?
X plus square.
Nah,
H minus X.
no.
X plus H.
K minus one.
I just thought I'd throw it out there. What essentially happens is your horizontal and vertical components, this is a real lazy way to say this, they just change places. And so on the left side, we have our y minus k. And then on the 4p is still there, and you don't know who p is yet. You do, you just don't know you do. And then the right side is going to be your x minus h. So if I have any chance of getting through this in the next 13 minutes or 16 minutes, whatever this is, I better get to hustling. So let's talk about this cast of characters. As with most formulas like this, you don't need to know who X and Y are. They're the structural components of the graph. Like, so we don't input, we're not changing them. However, the first one I want to talk about is H and K. So in either of these formulas, the point HK is the vertex.
So H is the vertex's X.
Right. So H is the vertex's X coordinate and K is the vertex's Y coordinate. Thank you for yes. What?
Is P our line?
It is not. P is something that hasn't really actually been addressed, but here, let me go back up and you'll get this super quick because you guys are pretty dang sharp. Are you ready? On this graph up here, P is equal to 2. And that may not be enough information for you yet. It is not. And I figured that that's what a normal person, a smart person would say. On this graph over here, P is 1.
Oh, it's the distance between the.
Amount of twos between them.
There it is. So what it is it's the directionally sensitive distance between the vertex and the focus. So, and I say directionally sensitive because you've been in math classes long enough to just know instinctively that when you go up, that's a positive, and when you go right, that's a positive, right? So like in this problem, you can see, and I'm going to draw a little, I don't have a lot of colors left. I'll use white. This white thing, I'm going to put a little arrow on it, is your p-value. And so that's the directionally sensitive number. So it's +2. It's a length of 2 in an upward direction. So P has a name. And I'm not huge on vocab. I like vocab when I feel like it's going to help us be better communicators. So I think if you could memorize this, it would help, because when I say it, I want you to know what I mean. P is called the focal distance. And there you have your entire cast of characters. So P is the focal distance. H and K are the X and Y coordinates, respectively, of your vertex. And it's those components that you need to write the equation of a parabola, which is interesting because then the question comes up, like, how am I going to do this when a math problem comes and says, okay, write the equation of a parabola whose focus is at 4, 3, and whose directrix is the line x equals, I don't know, -2. I mean, what right away is the missing component here? I don't know the focal distance. What else don't I know? I don't know the vertex. So in so many times in mathematics, what's the thing I need to do to empower myself to be able to do this?
Problem solve.
What's a good step to problem solve this? What's something I can always do to make myself better understand a situation? Yes. Draw a picture. And it doesn't even have to be a great picture. It can be as half-hearted as the ones I did at the beginning of the lecture. But the first thing I need to do is get my head around relativity. Where is the focus relative to the directrix, and how far away is it? And then when I, split that, like, I need a picture. And I think you'll find that even if I don't tell you you have to, for a great long while early on here, you're just going to draw pictures because you will. So the first thing we're going to do is we're just going to make a really half-hearted sketch here. I'm going to draw an x-axis and a y-axis. Again, not going for perfection here. And I'm going to go graph the point, the focus point, which I'll do in yellow to be consistent with what I was doing earlier. So I'm going to go to the right 4 and up 3, which is maybe right about here. Okay. And I can label that. I'll change back to white and I'll label it. So this is the number 4, and this on the y-axis is the number 3. Tell me about my directrix. What is he?
It's a vertical line.
He's a vertical line. Be careful. Remember that x equals is a vertical line. So I'm going to go on the actual x-axis to -2, which is right about here. And I'm going to draw a vertical line. Remember, x's are verticals. So through that point, I'm going to have to go back and fix that, but I mean, it goes without saying how important this is, right? Because now I can see it. Now I can see the situation, right? Yeah.
So would we not be able to take the distance between the directrix and the focus and then half that? And that
Eventually, that's what we wind up doing.
Okay.
Yes.
Okay.
Yep. And these are all just dots that each of us connects in our own time, right? And the quicker that it all starts to come together, the more corners maybe we can start to cut individually. But right now, I want a picture. I want you to have a picture. I need some numbers. I need this relative, like, what do we know right now? Which way is the parabola going to open? To the right, right? And tell me, is the p-value going to be positive or negative?
Positive.
It's going to be positive because not the distance, but that jump from the vertex to the focus is a rightward positive jump. So let's figure out, now that we've got everything mapped out, where the vertex is. Overall, how far is it from the directrix to the focus right now?
6.
It's 6. And of course, you've been around long enough to know that if you want to split 6 in half, you just go 3, right? And you can come back 3 from the focus or go right 3 from the directrix. Where do you wind up at? Right here, correct. So this point right here is going to be the vertex. And his coordinates now allow me to kind of open the door to writing my equation. All right, this is great news. So I can say now, every time I'm going to write this down, the vertex is at the point 1, 3. Huge. Got my H and my K. Who's missing?
Focal distance.
Focal distance, P. But I can see it now. I can see it with my own eyes. I'll put a little red arrow or a white arrow to indicate who he is. He's right here. He's this white arrow from here to here. How long is that?
40 volts.
It's 3. So we can say that P is equal to positive 3. At this point, we're going to pick the correct formula. And by the way, if you do watch the other video, you'll see I kind of stress this a lot, that you no longer need the focus and the directrix. Quite frankly, you don't even need your picture anymore. As long as you know that it opens to the right, you're good. What matters is these 3 numbers, 1, 3, and 3. And so I'm going to go and I'm going to choose the appropriate formula. Since it opens to the left or the right, I'm going to pick the one that starts with y minus k squared. Okay. So the formula, let me see if I can just grab it and move it. It'll be convenient. There we go. So if I just slide it down there. So we're going to use this one. Got it? I know. He didn't want to come along for the ride. If I tried to grab him, I would have gotten the P. So I was trying to avoid him, but yeah. So let's do this. Let's write the equation of a parabola based on a focus and directrix and now a vertex and a p-value. What's it going to be? It is not 4. Oh, okay. As long as you do 4 times 3. What's that going to
4 times 3
is? What's 4 times 3? So rather than writing 4, 3, let's just put 12. Great. And then what was the last part? X. Done. And the thing about this, by the way, is I'm a little bit reticent to do this, but like if you really wanted to just make this look more like what you're used to, you could multiply it out for the record. And I probably will never do this again. I will only if you ask me to, but like this side is y squared minus 6y plus 9, and this side is 12x minus 12. And for the first time ever, you're going to see a function. I'm not going to say that, like an inverted function that's like, you've seen inverses, but like this one's going to feel like it wants to be a parabola, but it's an inverted parabola. Check it out. So if I get x by itself, this currently now says y squared minus 6y plus 21 equals 12x. And then if I divide everything by 12, I get 1/12 of y squared minus 1/2. What's that? I was just dividing. I just want to see that as my a value. Is that okay? If you wrote y squared over 12, it would be okay. You good? Okay. Minus 1/2, so that's 6 divided by 12 of y plus 21/12, which is 7/4. So what's interesting is if we went to Desmos and typed in that and that, our graphs would sit right on top of each other. They're exactly the same. So it's kind of neat. I don't know. I think it's kind of neat. But anyways, all you're going to be doing today is just this. You're going to be obtaining that and typing it in and moving on your way. Got it? Let's practice another one.
Sigma.
Is that sigma?
I think it is.
Is it sigma alpha? Whee! This time, let's do focus at 6, 1. And let's do the directrix as a line y equals 7. I mean, already right now, you're math people. What do you know already about generally how this parabola is going to open? You don't have to be specific. Just tell me something. It's up or down because the directrix is a horizontal line, right? So we know it's going to open up or down. The question is the focus above the directrix or below? And again, I'm not saying everyone has to be like me, but I don't know. I really struggle on these if I don't, at least while I'm knocking off the rust every year, I gotta have some pictures, man. So I'm going to draw my axes and then I'm just going to give her a quick sketch. So the directrix is way up here at 7, y equals 7. And then my focus is at 6, 1. And that point is to the right 6 and up 1. So maybe something like about here. That's it. I mean, visual, that's it. I got this. Which way does it specifically open? Down. And at this point, I would put the vertex in and I just kind of eyeball that it's about halfway in between those two. So maybe right about there. And it's now that you write the first important thing that you write, and that is what are the coordinates of my vertex?
6, 3.
6, 3 is not correct. It is 6, 4. The distance, in case you're wondering what just happened, this distance from here to here is a distance of 6,
Mhm.
which means you either have to climb up from the yellow or down from the red a distance of 3, right? So are we all okay with the vertex being at 6, 4? What is P? Yeah, you guys are pretty amazing. It's negative because vertex down to focus, negative movement 3 because, well, it's just 3. It's half a 6, right? So having said that, we're going to grab the right formula to use. And because it's an uppy downy, we're going to pick the one that has x being squared, that not the inverted one. When x is squared, it's a regular function. When y is squared, it's the inverted funky one. So what's this going to say?
X minus 6 squared equals 12.
It's not 12. It's negative 12 times
Y minus 4.
done. I said I wouldn't do it again, so I'm not. But if you wanted to see what that looks like in function form, you could multiply it out and then get y by itself and actually see what you're used to. Y equals ax squared plus bx plus c. But this is just the conic version. This is the conic form of a parabola, not the standard form.
Is delta going to give us like a little graph?
Let me give you a quick look. I hope I'm still recording here. Yeah. So let me give you a quick peek about what it's going to look like for you. You'll appreciate Delta does a lot of the annoying stuff kind of up front. So I asked Delta to give you guys a mix of level 1, level 2, and level 3. And I got to be honest, having looked at them, I wasn't really sure what the difference was, but they're usually pretty good about the levels being something about them is more difficult. Maybe they'll involve some fractions or something. I don't know. Let's take a look at a simple level 1. So what do you see right away that's nice?
The directrix is in
Yeah, that's really what I was going for. And the question was so obvious that it was actually a dumb question. But the fact that they've already graphed it for us is really nice. I'm going to zoom in a little bit so you guys can see a little bit better. So we've got it's a little annoying that the directrix is right on the x-axis, but I like that it's so visual. So right now, I don't even have to make a sketch. This is rad. Just straight up tell me, what are the coordinates of my vertex?
-8 and 3.
Good job. So -8 and 3. And if you wanted to sketch it in there, Delta might be bossy and ask you to do something. Let me see if it asks that of you. Yeah, no, it's not gonna tell you. Sometimes they say you have to do this and this before you submit your answer. So you just know that the vertex is here. What's P? Oops, I'm on the wrong tool there. Yes. It's also
For every example.
I don't know what's going on with 3s. For the record, it's starting to kind of freak me out a little bit. But yes. So what would this equation be? So it opens up. So we pick the x squared formula. What's it going to be?
X plus 8
Nice.
squared equals -12 again. Or no, 12.
Positive 12
Yeah.
times
Y.
y. Sorry about
X.
that. No, it's not
Y.
x. It's you
Y.
do what you do. I'm just messing up.
Y
Equals y.
-3.
Good job. Yep. And again, you just type that in. Do you guys all remember how to do exponents on your keyboard?
Shift.
Shift 6.
Yeah.
Yeah. So you just head down here and then you just type it in parentheses, x plus 8, close parentheses, shift 6 squared, right arrow down to get out, and then equals 12 parentheses y minus 3. And they program Delta Math nice in that, like, if you type it in like this, it says yes. But if you messed with it a little bit, just for fun, it'd still take it. Like, it's pretty good about understanding core mathematics. Like, it's not about the form that it's in, it's about the
like no.
system that it the system that it, or the the situation that it represents. So you guys feel like you can do this? Nothing to it? Great. So what you're doing today again is you're writing equations of parabolas when you're given the focus and the directrix. And if I were to go and take a look at a level 3, oh, so in level 3 they don't give you a picture.
Oh,
I should have probably picked up on that. What's level 2? So level 2 they give you a picture, but I don't know what's.
why is the directrix dog?
It was dotted on the last one. You just couldn't see it. So I think they do that so you don't accidentally do something crazy and think that it's the y-axis or something. I didn't know I'd worked you right to the bell. Obviously, Monday will be a work day, so just enjoy, take a few days off, and then on Monday we'll work this in class. Right up to the wire, because the bell is going. Yeah.
Before I go.